This is a video going over review problem number 13 on 6.11. And this relates to finding a sine function that describes what's happening in each situation. And the key to looking on the initial problem, and this applies to A, B, C, just A, B, C, I thought there was a D, A, B, C, is that the period is 24 hours. So right away, if we think about the sine function, we can find that B value or the coefficient of X, because the B value is going to be equal to 2 pi over the period. So we say 2 pi over 24, or my B value is pi over 12. And that's going to be the case for all of these. So what does that mean? Well, we need to find the amplitude. We need to find if there's a negative or positive in front of the amplitude. We then need to figure out the vertical shift and the C value, like left and right. So for a situation, it's saying there's a high temperature is 10 degrees and the low temperature is negative 10. And we know negative 10 is at 4 a.m. And t equals 0 corresponds to midnight. So that's important too. And based on drawing my graph, it says that the graph is, and this is in the initial problem, it's saying that it's decreasing at midnight. So I'm going to achieve, after midnight, I'll achieve this low at 4 a.m. So let's do 1, 2, 3, 4. At 4 a.m., I'll have a low of negative 10. So I'm going to write 4, negative 10. And then, so it's important to know that between a low and a high of any sine or cosine graph is half a period. So because the period's 24, half a period's 12. So 12 hours prior to 4 a.m. will be my high point of 10. So let's go back 12 hours, which means, so I'm going to go back from midnight, 8 values here. Okay, so this is going to be negative 8, 10. Actually, I'll write it up, the high point here. So it's going to be at a high point, negative 8, 10. Okay, and so again, high point is at the y value is 10, low point's at negative 10. Halfway between that is the vertical shift. So the vertical shift in this first case is 0. So it's just the midline is the x-axis. And the amplitude, well, how far from the midline would be 10. So the amplitude is 10. And one thing that I found helpful here is that, so it's going to cross the midline halfway between my upper value and my lower value. So halfway between negative 8 and 4 will be negative 2. So I've got negative 2, 0 there. It's just making it easier. I guess you don't have to use that. You could just plug in one of these points to find C. But again, I found it easier to find that midpoint. So, all right. So kind of looks like that. It's pretty elongated. So then when I think about what I have here, so again, sine. So if this is my starting point for sine, it's starting here and because remember, sine starts in the midline. Normally sine starts in the midline and goes up though. But in this case, it's starting on the midline and going down. So I'm going to put a negative in front of my amplitude. And then I've got, and the amplitude's 10. And sine, I know B is pi over 12. And in this case, if the period, if we'd already done the period change, I will put the pi over 12 outside from the horizontal shift. And I will say, okay, if after the period's been changed, this has been shifted to the left 2. So I would say x plus 2. And then I'd say, and there's no vertical shift. And you could then say, all right, this is negative 10 sine pi over 12 x plus pi over 6. You could write it like that. So say you weren't comfortable with that. Say instead you wanted to just plug in a point, you could have done that too. So I could have plugged in either of these points to find the C value. In other words, I could have said, okay, negative 10 sine, so pi over 12. Let's plug in the point for negative 10. So for the y value, I'm going to put negative 10. And for the x value, I'd put 4 plus pi, plus c. Sorry, what I'm trying to find. So I've got, if I divide by negative 10, I get 1 equals sine pi over 3 plus c. And then I think, okay, if this is my starting point, then this here, and remember there's a negative in front of the amplitude, so this is corresponding to pi over 2. So I would say pi over 3 plus c equals pi over 2. So c equals 3 pi over 6 minus 2 pi over 6, or pi over 6, which is exactly what we got here. All right, so it's all about setting these up. The next problem, we know a point. The temperature is midnight, and high and low temperatures are 20 and negative 10. Okay, so remember it's decreasing when it's passing at midnight. So I know this point, let's say this is 10, 20. So I know the point at midnight, which is 0. I know the point 0, 12.5. And since it's decreasing at midnight, sometime after midnight, I'll have a low point of a low value of 10, and sometime before I'll have a high value of 20. But that's kind of all I know right now. So, but that's fine, because here's what we know. Remember, we already know B from the initial problem. And because I know the high and low being at 20 and 10, I know 15 will be my vertical shift and 5 will be my amplitude. So I've got y equals, but again here, because it will be, as it crosses, the midline, by the way, would be above this, right? The midline's at 15. So if this is my starting point for sine, then it still is going to have a negative in front of the amplitude. So I'm going to say negative 5 sine, still doing this pi over 12x plus c. And the vertical shift here we said was plus 15. So now let's just plug in this point, 0, 12.5. So 12.5 equals negative 5 sine. 0 for x will be in that 12, pi over 12 times 0 is 0. So it's just sine c plus 15. Subtracting 15 and dividing by 5 is going to give me negative 1/2. So I've got negative 1/2 equals sine c. And then let's see where, going to our graph here, if this is my starting point, then 0, 12.5 is in quadrant 1, but actually it's not negative, because we would have negative 2.5 divided by negative 5. It would be, positive 1/2. So in quadrant 1, we'd have C being pi over 6. And so that's the value of C. Okay, let's do one more here. The temperature varies between 10 and 30, and the average temp of 20 degrees Celsius first occurs at 9 a.m. Okay, so that means I know the point at 9 a.m. I know it's 20 degrees, which is on the midline. Woo! Okay. So if I go, again, we have got midnight, then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And the midline is at 20, so let's do 10, 20, 30. So 9, 20 is a point we know. And then the temperature varies between 10 and 30. So I know when it crosses that midline, when it crosses midnight, it's decreasing. So if it's at the midnight at 9, then let's figure out where is it at the low point. I know the low point's at 10. Well, how far from the midline will that be? So remember, the period is equal to 24. So if I think dividing that into fourths, so it will be at its low point at 3. So if I divide this by 4, I get 6 away. So it'll be at the low point at 3:10. And then, of course, it'll go back to the midline at 6 away from that. So let's go 6 away. 1, 2, 3, 4, 5, 6. So -3. It'll be back at my midline. And then it'll be the high point 6 more from that. Okay, so let me just draw my midline here. So this low point we just said was 3. We actually don't even need to use this, though. The low point was 310. Okay, so for the sine function, so we could use, since we know this midline point, we could use this as our starting point. And from here we know, because it's down below, we know it will go up from this starting point. So I know my amplitude is 10, so I'm going to say 10 sine. A period is pi over 12. And if I'm using this as my starting point, I know it's shifted to the right 9. So after the period change, I'm going to say x minus 9, which is why I have it, the pi over 12 outside the bracket. And then the vertical shift is 20. So I'm going to say y equals 10 sine pi over 12 x minus 9 pi over 12, or 3 pi over 4. Plus 20. Now, if you weren't comfortable with the shift x minus 9, then you could have just plugged in the point, any of these points, just to find your c value.